Welcome everyone to this webinar. I'm Eva Lainola from the OECD Secretariat, and I'm pleased that you have joined us today for the launch of our publication on a chemicals perspective on designing with sustainable plastics. So a little bit about how today's webinar will unfold. So I will provide you with an overview of the document, the publication, and 4 associated case studies, which have all been published today. You can find all of these documents now via this short URL that you see on the screen. So all of the documents have been released today. Following that, I'm very pleased to be joined by 3 people. First of all, Z Zerk from Australia will provide some perspectives from Australia on this project. He was part of the expert group that was formed for this project at the OECD. And then similarly, Suzanne Weyers-Vanderloop from the Netherlands will provide some perspectives from the Netherlands, and she was also part of the expert group supporting this project. And then we'll turn things to Miriam Trajafachka from Target, who will talk a little bit about Target's journey towards more sustainable design, and also some of their chemical aspects and some perspectives from Target on this initiative. I encourage you to also put any questions that you have in the question and answer box that you can find on the bottom of your Zoom menu. Rather than using the chat for questions, please use this Q&A function. And we'll have some time at the end for some questions and trying to answer some of your questions. So this initiative was conducted under the OECD's Chemicals and Biotechnology Committee and the Environmental Policy Committee of the OECD, and in particular the Working Party on Resource Productivity and Waste. So it was a joint initiative within these groups at the OECD. So today we're happy to announce the launch of this document, which was really 2 years of work culminating to get here. And really what the purpose of this document is to integrate sustainable chemistry thinking in the design phase to create inherently more sustainable plastic products. And also to equip designers and engineers with some knowledge on how to manage the complexity when they're designing to find the most sustainable plastics so that we can support better outcomes from a chemicals point of view. So this work is really starting from the perspective that a plastic has been chosen as the material of choice for the particular product. Of course, there's a process before that where you could think of alternative material choices, but that's not what's addressed in this document. It's really looking at, if we're going to be designing a plastic, how can we do it more sustainably from the chemicals perspective? So if you think about plastics design and chemical selection, really any of the chemicals that you're choosing at the design stage, whether they be the polymer or the plasticizer or pigment or processing aid, really has an impact along the whole life cycle of the product. So depending on the chemicals that you choose at the design stage, this will impact sourcing. For example, if you can use virgin material or recycled material, or also resourcing of the additional chemicals that you use within the plastics. It'll also influence your product manufacture stage and the types of emissions that could occur to the environment, or exposures to the occupational in the occupational setting, or releases that also could impact human health. Also, the chemicals that you choose or the polymers you choose will impact exposures during the use phase of the product, if they can be released during that period. And it'll also influence the end of life. So if the product can be recycled, if it has to be incinerated or landfilled, and for example, if it has to be incinerated, what are the types of releases that might occur from the chemicals or polymers chosen? And within this design stage, then there is a need for making choices between different trade-offs that arise. So really, delegates wanted us to look at how can we articulate more of the considerations for sustainable design of plastics to increase awareness of design teams of the chemical related environmental and health impacts that could be the result of the choices that they make. And this becomes even more complicated by knowing the number of chemicals or polymers that could be used. There was a publication earlier this year that indicated that greater than 10,000 chemicals and polymers can be used in different types of plastics. So in order to get to this document, what we did with the expert group is conduct 4 different case studies to inform the considerations. And we really wanted to do this to have a more ground up approach to be able to consider the more general learnings. So we conducted case studies in the plastic packaging and construction areas. And then really looked at what were the general learnings from the case studies to develop the more general considerations document. So these 4 case studies were also published today, and I'll just reflect on them a little bit on this slide, but I do encourage you to consult them as they are quite rich examples of the different considerations that come into play for chemical selection within these 4 different types of products. So the plastic packaging case studies were drafted by Partners for Innovation, and the construction material case studies were drafted by Healthy Building Network. And then these were then built upon by comments and remarks from delegates and stakeholders. And they also really reflect the trade-offs that need to be made and the complexity of the process when you start to look at the impacts of chemical selection all across the life stage. As with the general considerations document, these are all starting from the premise that a plastic material will be used. And they identify the key considerations for environmental or health sustainability. Also, I think it's important to mention that really these case studies were made for the purpose of drawing together these learnings and general considerations. And that was really the basis and the purpose of these case studies. And so if you were actually to make decisions about material selection, there would be other factors that would come into play beyond what's included in these case studies, such as other economic or social factors, and then also potentially consideration of life cycle assessment or a more fulsome review of regulatory restrictions in some of the areas that the case studies fall into. So then if we move to the general document, so the chemicals perspective on designing with sustainable plastics, this is really, has been designed in a tiered approach in terms of the design principles, the sustainable design goals, and then the general considerations on the life cycle. And again, it's really focusing this thinking on sustainable chemistry at the design stage. Initially, the document articulates the design principles of sustainable chemistry and engineering as outlined by the American Chemical Society. And these are maximizing resource efficiency, eliminating and minimizing hazard and pollution, designing systems holistically, and using life cycle thinking. Then the document also articulates what we see as a minimum set of design goals that should be considered by designers. However, depending on the level of ambition of the company, these can also be expanded. So it's really to select materials with an inherently low risk or hazard, select materials that have a commercial afterlife, select materials that generate no waste, and select materials that use secondary feedstock or bio-based feedstock. Finally, the document goes into quite a lot of detail on considerations at each life cycle phase. So there's a chapter focusing on each life cycle phase of the different types of considerations that come into play at that phase and what some of the trade-offs are that might arise during material composition. Of course, all these life cycle phases then need to be brought together to look at whole product optimization. And the development of this document was supported also by partners for innovation. And because there are so many trade-offs that need to be made, and we're not going to go into this presentation, but the document also outlines an approach that designers can take to think about how to prioritize their design goals and what are things that are must-haves from the design conceptualization and what are nice-to-haves. So for example, at a higher level for the manufacturing phase, some considerations are outlined here. So for example, to select a manufacturing technique that generates the least emissions, uses the least processing aids, uses non-hazardous or least hazardous chemicals, minimizes worker exposure. Also, you have to think about manufacturing on a systems level, and at all phases ensure transparency in the chemical composition is being communicated throughout the value chain. And just a couple of examples of trade-offs. So for example, if you choose, if a designer wanted to use a new processing aid, they found that the processing aid made for a better product. It could be produced faster. They'd also have to think about what are some of the implications of using that processing aid. For example, are there additional risks to the health of the occupational population from using that processing aid? Does it change the manufacturing process? So for example, for cleaning of molds, do other chemicals then need to be used? Also, then what are the hazards and risks if some of that processing aid is remaining residual in the product in terms of the use phase and the end of life phase? Or for example, perhaps the designer comes up with a new innovative material that uses less hazardous chemicals and uses less material. So it looks like a very good choice. However, perhaps this innovative product cannot be recycled because the technology doesn't exist. So these are all sort of different aspects that should be considered in the design process. So some overall reflections. The complexity, as you'll see when you go through the document and the case studies, is high. And even in this document, we've tried to aim for something that's not too generalizable, but it has a slightly more level of detail, but that could still be applied across products. So the complexity is high, but it really can't be ignored if we want to move to better solutions and greener products. Also, a systems level approach is needed. We can't work in silos in order to apply such a process. But because a systems level approach is needed, it also requires involvement of many stakeholders and input of different types of expertise. You can't expect one person to hold all of this knowledge, and it really needs involvement across the value chain. And due to this level of complexity in the systems approach, really it also relies on a lot of information to be able to inform decision-making. Because in the decision-making, actually, it will lead to different choices, also between different policy priorities. So this document is really one piece of the puzzle towards more sustainable design, really looking at the role of chemicals and how if we're making plastics, we can think more critically about the chemical selection process to move towards more sustainable design. Of course, in the larger picture, there are other factors that come into play for sustainable design, and also economic and commercial realities. But really, this is our contribution from the chemicals angle. Just a few notes on the future work that we're planning to do at the OECD to follow up on this report. So now that these considerations have been articulated, we want to look at what are the economic, technical, or regulatory barriers to achieving this more sustainable design, and how could policy approaches help. So we'll be examining flexible food grade packaging specifically to look at the barriers for implementing these types of considerations. And then also discussing what are things that governments could put into place to help further incentivize the sustainable design for these flexible food grade packaging. And we're now working with the expert group to plan a workshop for the second quarter of 2022 on this aspect. So with that, I'd like to end my presentation by just also encouraging you to go to that link to download the documents and also share them with others. And to continue to communicate the importance of chemical considerations at the design stage in order to have more sustainable plastics. So I'm going to stop sharing my screen for the moment. And at this point, I'd like to invite Z Zerk from Australia to provide us some perspectives from the evening, actually nighttime, I guess, now in Australia. So Timothy, over to you.
Yeah, we've just gone into the wee hours of the morning. So thank you, Eva. And apologies if I stumble over a word or two here. It's been a long day. Thanks for the opportunity to share, Eva. It's been great to be involved in this project. I guess I wanted to share just a couple of quick comments from our perspective on sort of the context around this piece and why it's come at such a useful time for us. And it's been such a useful exercise for us as well. So I guess Australia, like many of you, our international friends, we're taking a range of actions to address plastics, particularly plastic waste, as we pursue a more sustainable, more circular economy. So to date, that's focused mostly on things like banning the use of some problematic single-use plastic products across the different jurisdictions within Australia and kind of harmonising those regulatory approaches. We also have published this year a national plastics plan, which sets out sort of national targets and coordinated action that we'll take to improve the sustainability of plastics. And then we've also, in the last kind of 18 months, implemented what really is a world first in terms of the export ban on exports of low quality waste plastic overseas and looking to kind of take more responsibility for those wastes onshore in terms of upscaling our recycling capacity and capabilities. But I guess most of the action that we've taken to date has been on plastics at a macro scale, so products as a whole. And at the same time, interestingly, we're seeing a greater awareness emerge domestically amongst government, amongst businesses and the community about the impacts of the, I guess, the invisible components of plastics. So moving down to that kind of micro scale and microplastics, even further down into the nanoscale plastics, and then beyond down to the atomic or chemical scale. And we're seeing an emerging importance of what we select as the raw materials and the chemical additives for use in plastics. So I guess that decision about what's used at the chemical selection phase has important implications. I mean, it's not just as you touched on, Eva, there about the emissions that are associated with your choice. It's also about the potential risk through exposure to additives or those kinds of things. And increasingly, we're seeing as well this added dimension of importance from choice about the chemicals determining the suitability of that plastic to enter a circular economy. So we know certain polymers, certain additives just can't be safely and efficiently recycled, and others can. They can enter the circular economy, but only under precise conditions and conditions that aren't always in place. For example, between our east and our west coast is 2,500 miles, and the infrastructure for plastics recycling differs significantly across that expanse. So a polymer that's recyclable on one coast of the continent may not be on the other. And so we're seeing, I guess, that there's this increasing importance placed on the chemical decisions made at the beginning of the product life cycle, and that affects the viability of these products for a circular economy, which for us has really sharpened the importance of how we carefully select raw materials and additives at the beginning of the product life cycle. We want to facilitate safe material recovery, reuse, recycling, and we want to minimize human and environmental impacts. These challenges for plastics are difficult ones. I don't think anyone would disagree with that. Balancing the benefits of plastics with the impacts. You're trying to unpick at the same time the technical complexities in terms of plastics chemistry and support industry ultimately to move towards more sustainable plastics through careful, informed chemical design. And so for us, we were really pleased to be part of this timely initiative to develop supporting guidance for designers to improve that sustainability. I might just add that this also provided, that the development of this document provided us a great opportunity, or I guess a great excuse, to draw together some of our key stakeholders across business, government and communities to discuss the challenges, and particularly those common challenges, the common priorities, but also the differences. So we use this project as an opportunity to draw together representatives across Australian business, government, non-government sector, and to draw on their perspectives to help shape this document so that it would be balanced and a usable resource. And that really helped us identify where as colleagues we shared common challenges or aspirations and to understand out what those priorities were. So I guess that's my kind of 2 cents behind the context for this document. But if I can beg 30 seconds more, I did also want to share just a couple of reflections on the approach to developing the resource. And Eva, you've outlined that already. And I think it's been a really good one, combining kind of a bottom-up and a top-down approach. So from a bottom-up perspective, using the 4 case studies as examples of sustainable design in action, that provided, from our perspective, a really sensible way of drawing out common design principles that cut across different plastic product types. And it'll mean that this document and the principles in it are grounded in real-world experience, which is important. And then from the top-down perspective, not ignoring the historical thinking, but drawing upon it around the kind of experience in sustainable chemistry, and particularly those design principles for sustainable chemistry and engineering, provided a really useful scaffold to kind of hang those principles on. And then putting that all together into a resource that sets out what are really practical steps and principles that designers can apply, we think will give this the best chance at being a document that's useful for practitioners. So this is not just a kind of theoretical policy tool, but a practical one. So I guess we've been very pleased to be involved. Our thanks to Eva and the team at the OECD for organising, to the consultants that were involved in pulling this together. So it's Partners for Innovation and the Healthy Building Network. There's a mammoth coordination exercise. And while I've got the floor, I wanted to thank as well our domestic stakeholders that were involved in this. So we had our industry group in Chemistry Australia, our main research organisation, the Commonwealth Scientific and Industrial Research Organisation, or CSIRO, and the Australian Packaging Covenant Organisation, as well as the other universities that were involved. So it was really great to bring them all on board in developing this resource. And we are, as Eva alluded to, turning our attention now to implementing this in the Australian context, and look forward to further engagement with the OECD on this topic. Thanks.
Thanks, Tim, for those reflections. I think it was really interesting to hear, from many perspectives, what's going on in Australia in terms of some of your initiatives on plastics, but also the challenges as well. You mentioned, different capabilities in recycling in different parts of the country, and if we expand this to the world, it's certainly it's something that needs careful consideration also in the design phase. And I think it was really nice to hear as well about the growing recognition from both public and stakeholders of the need to drill down to the chemicals stage if we're really going to have more circular solutions and to move to more sustainable products and sort of the circular economy approach. So I think Australia and all of the stakeholders also in Australia who contributed to the document and to the discussions. And we do hope that it'll be a practical tool that can be used. So I'll move now to Suzanne, who will provide us some perspectives also from the Netherlands. Thanks, Suzanne.
Thank you, Eva. So I'm Susanne Weijers van der Loop. I work at the Dutch National Institute for Public Health and the Environment. And together with colleagues, we also contributed and participated in the expert group. And it was a very valuable experience. I think, we fully support the documents and the reports, and they're very important because they show, for instance, like already that has been said, the transparency that's needed on polymers and on plastic composition, the life cycle perspective, the importance of the life cycle perspective, and not only one life cycle, but multiple life cycles. And also the value of commercial afterlife, for instance. And what we see in the Netherlands is we're recently, the last years, we've started, like many other countries, a plastic pact, where there's voluntarily commitment to make the plastic life chains more sustainable and more safe. And I think this is a very valuable addition, this work, because it really underpins the importance of like that has been said, the need for information on the chemical level and transparency on the chemical level, because that's basically really the only way if you want to move towards more safe and sustainable circular plastics. We need that kind of knowledge. And I think, the working group also is a very valuable platform, because it enables us to work together, to collaborate with all the different expertises from all the different countries, which is really necessary. I think everyone agrees, if we really want to move towards a safer and sustainable plastic economy, that these steps need to be taken. And I think that the cases provide a very valuable starting point. And just also again to echo what Eva said in her presentation, this is a starting point really from a plastic perspective, and it would be very valuable if now we can take more innovative cases looking at a certain societal need or a specific function or application, and then looking at plastics, but also at the alternative materials to see what is truly the most safe and sustainable material or product for a particular societal need or function. And in some cases, of course, that's really plastic, and in some cases, this may be not. So I think it's really good to widen the scope. But I think most importantly, what we also see with these reports and cases is that we have to learn by doing. So it will take several cycles, quite a while before we're really get more a grip of what truly safe and sustainable means. And the only way we can get there is by trying and applying and by learning. So I think these cases are very valuable because they enable us to learn, to evaluate, to apply, and learn again, adapt. And we really have to think, I think, stay flexible in that way to realize that it's such a challenge we're facing now. So we have to act now and with the best knowledge at hand, act. And I think these reports and cases really help with that. And then we have to set up a system where we can monitor and see what we can learn along the way and how we can keep improving our materials, not only plastic, but our materials, just to get to the lowest possible environmental footprint for any product that provides in a certain societal need. So we're very happy that we can learn here in this expert group and participate and collaborate. And I really look forward also to the next steps. Thank you very much.
Thank you very much, Suzanne, for your reflections also from the Netherlands. And I think, I like this idea very much about learning by doing. I mean, I think this is also how chemical legislation basically, across the world has continued to improve, is that you don't have the perfect solution to begin with, but you start with something, and from that you learn and you build upon that to make better and better decisions and have better solutions. And I think you nicely underlined the need for information and transparency on a chemical level. Indeed, this is a challenge that we have with many products, as also they, due to the global nature now of life cycles, our value chains as well, and to better be able to have this information as it's the basis then for the decision making that comes along. And we do look forward, yes, to now moving to look at flexible food grade packaging and seeing if we can have some practical solutions and ways to improve sustainability in that particular product sector, and see how we can bring the learnings from this to bear, and also the expertise of delegates from across countries. So I'd like to now move to Miriam from Target, who will have some perspectives on Target's journey towards more sustainable design and some of her additional reflections. So Miriam, go ahead if you can share your slides.
Thank you, Eva. Thank you for giving Target the opportunity to share good practices on plastic eco-design with chemicals. So I'm Miriam Trujé-Fasca. I've been working at Target for 6 years. I'm a biochemist from my education, and I am today a Public Affairs Director and Sustainability for Target EMEA division. I will give you an introduction on how Target has been developing its approach towards the sustainable design of vinyl floor coverings, as it is one of the examples that have been chosen for the case studies in the report series. Target is a global floor covering manufacturer with more than 140 years of history, operating always close to its customers. Target joins 12,000 employees in 100 countries and sells 1.3 million square meters of flooring every day. With that scale, our products are installed in every places where we live, we play, we learn, we heal, we care, and where we work as well. Target has set a business strategy embedding a shift towards a circular economy. By doing so, Target will contribute to tackling climate change and its mitigation, only using good materials, safe for the people and the environment. And to do so as well, as our products are used indoors, Target raises the bars in its industry, exceeding the most stringent regulations on indoor air quality. Indeed, circular design is at the beginning of every product development and is part of how we operate from eco-design to closing the loop with the development of our own restart framework for collecting and recycling products at their end of use. To shift towards a truly circular economy, we chose cradle-to-cradle principles as our North Star. We apply it to all our product range. It includes, of course, vinyl floors, even though they are not eligible to cradle-to-cradle certification. We apply the 5 principles. Material health is the basic one. The product circularity is as well the second aspect. The renewable energy, climate requirements is how we operate as a good stewards of resources. We have as well developed closed loop for water usage in our factories, and we take care of social fairness as well in our activities. Just to mention that Target has the level platinum in the evaluation of our social responsibility by EcoVadis, which is a well-known platform for sustainable sourcing, which is used by major customers of us. So first of all, cradle-to-cradle material health assessment give us and our customers the peace of mind. As of today, we have assessed more than 5,000 ingredients. The tiny chemicals entering in the formulation of our product are therefore assessed. They are third-party evaluated by an independent expert in toxicology. And the evaluation is about the health impact, the environmental risk in the context of the intended use. To do so, our partner EPEA is cross-checking many different toxicological databases beyond the well-known regulations. This allowed us during the last 10 years to optimize our vinyl formulations and develop expertise in voluntary substitution of hazardous substances and even controversial chemicals such as biocides. We also phased out phthalates from our products and replaced them by alternative plasticizers that are used for toys or for food contact. We're committed to full transparency. And here I can rebound to what was said before by Tim and by Suzanne. Transparency is key and is fundamental for a circular economy. We are committed to full transparency about the material content, and we go down to 100 ppm, 0.01% of the composition and the formulation of our products. It's in the form of what we call a material health statement, providing the result of the risk assessment. It is third-party verified, and it's unique on the market because it gives you as well an overview of the risk that can represent each substance that are in our product. And on the slide, you can see just one of the many MHS we have for vinyl products and for all other products of our portfolio, where you see the detailed composition with the CAS numbers and the results of the evaluation from the consultant. We see as well something important, and we were talking about regulations. We see the material health statement as a way to frame the transparency. And for us, it is really aligned with the concept and could even be a model for developing future product and material passports in regulations. As a result of what we do, as I mentioned, we close the loop on PVC and use it responsibly. We select our suppliers with safe production criteria. We have chosen safe additive to use in our materials, and we heard before additives are extremely important in the sustainability of plastics. We deliver to the market low and ultra-low VOC emissions from our products. Of course, to shift to a circular economy, we need to have recycled content. So some of our products have up to 43% of recycled content. And indeed, we recycle, our products are recyclable. Through our Restart program, which was, as I mentioned earlier, our in-house collection and recycling scheme, we are able to collect and recycle post-installation vinyl floors, waste, and today, phthalate-free post-use vinyl floor coverings. Recycling has benefits for resource protection. It reduces waste. It reduces as well carbon footprint of our product. As example, we have been able to measure, compared to a conventional incineration end-of-life scenario, how much CO2 emission we can avoid by recycling vinyl floors, for instance. When we recycle 1 square meter of post-use homogeneous vinyl, we can save 11.8 kilograms of CO2 equivalents. So this shows, again, the important contribution of circular economy to the climate mitigation. So today, plastics are demonized for good reasons. There is no question about it. But we can see that short-sighted vision could lead to an unsustainable material choice, potentially increasing pressure on bio-based resource, biodiversity, land use, water usage, and increased pollution as well due to the needed chemicals such as fertilizers or pesticides. OECD, with the series of reports published today, really provide a new perspective with an unemotional state-of-the-art, state-of-research report that can help sustainable chemicals management for eco-designing plastic products, helping identify and managing trade-offs. Target indeed welcomes this set of reports and guidance documents. And I hope my short presentation confirms that our experience as an industry confirms that it is clearly possible to do so at industrial scale. Thank you.
Thank you very much, Miriam, for the perspectives from Target and providing us information on the innovation that the company has done, both in terms of the product composition, but also in terms of recycling. And one of the things that I found particularly interesting was the level of detail that you provide on each of the materials that you have in terms of its chemical composition, and really providing that very transparently on your website, so people, consumers know what they are choosing and can make also a selection for themselves. So if Timothy, if you can also turn on your camera, and if I can bring all the speakers back in. And if Miriam, you could stop sharing your screen, I'll take some of the questions that have been sent in via the Q&A function. Maybe I can start. So there are a few questions on alternative materials, so plastics versus glass, or if we considered alternative materials. And really, this was not a function of this particular project. but it's also something that makes a lot of sense to do if you're thinking of designing a particular product. To start with, thinking about which material is best suited, and perhaps also consider life cycle assessment between different types of material. But I can just specifically say that it was not the focus of this work. And also one other question mentions additional pillars of sustainable design, such as social and economic considerations. And again, fully agree that these need to be taken into consideration in a broader picture of sustainable design. And we were really focusing our challenge on looking at the health and environmental impacts from chemicals and how we can improve that portion of sustainable design. And now maybe I could get maybe both Timothy and Susanna to reflect. There's a couple of questions regarding bio-based material. So one is regarding, can we have non-bio-based material that actually has a lower environmental impact and considered to be more sustainable? As well, there was another commenter raising that would we have some caution to raise regarding the very frequent promotion of bio-based and biodegradable materials, greener plastics. And the document does go into some aspects of that and considerations to think about in terms of using or not using bio-based or material. But maybe I can start with Timothy.
Yeah, thanks, Eva. That's actually what I was just going to say in terms of the bio-based materials. I think the document reflects on the other considerations that have to be taken into account there in terms of, other socioeconomic impacts and considering whether you're sourcing those materials from land that could be better used for other purposes, and then sort of weighing that up in comparison to the emissions gains or other benefits. And I think it comes back a lot to what you've prioritized as your key design principles that you want to achieve, whether it's emissions reduction or whether it's overall hazard reduction, or how you organize those design principles will significantly influence what your final decision is about the best way to go there. And in terms of can fossil fuel derived plastics have lower overall emissions than bio-based? Yes, they can, depending on how those are produced. But again, it's just one component of a multi-component system in terms of material selection. I probably won't delve too much into the biodegradable or compostable plastics. That's a murky area, obviously, so I won't wade too far into that one. I can leave that one to Suzanne.
That's excellent. No problem. Thanks. Yeah, so very good points, and it's not a very satisfactory answer, but it really depends on the application, of course, what material is most sustainable. And for bio-based materials, indeed, land use and biodiversity are very important topics to take along. You want to avoid, of course, food competition, just to give an example. And what is also, like what has been said, more details are in the reports, but also the PACE platform for accelerating the circular economy has published action agendas for plastics, for circular plastics, and they have also shown on a high level trade-offs that occur when making plastics more circular. And there's what's been said there as well is that we do not know sufficiently enough about bio-based plastics to say what actually the economic and the social impacts are, but in some cases also what the health impacts or the environmental impacts will be. So that will be really dependent on the application and the type of source that you use. So that's very important, I think, to take into account. And with biodegradation, it's also very complex because lots of plastics obviously are persistent. but persistent does not mean that they do not break down. They just break down very, very slowly, forming like a secondary source, for instance, like a legacy source for microplastics in the environment. And currently there are many, many different types of standards and guidance on how to measure how degradable plastics are. And of course, there needs to be more harmonization in this and more clarity on not just whether a plastic is persistent or not, but on like how slowly it degrades and then what kind of particles it forms. So there's lots to learn on that as well, I'm afraid.
Yes, it's a complex area. You know, both again always trade-offs, right? So, Miriam, maybe I can go to you with a question, and it was there was a question about obtaining information from your suppliers regarding chemical substances in their products, and if you found that easily accessible and detailed enough to do cradle-to-cradle certification.
Yes. It's a very good question indeed, and it has been really, really where the benefit of working with a third party independent to support us in setting the dialogue with our suppliers was key. Indeed, like any other business, our suppliers want to protect their intellectual properties and their production and so on. So sometimes we have proprietary information that cannot be disclosed. And we can understand that because it is strategic. So with our system, having an independent partner for evaluating chemicals, we have the possibility to have a full dialogue between our consultant and our supplier. With the only information that will be available to us and to our customers through the MHS about the result of the evaluation, but not the content of the material. This said, our consultant and our suppliers would have set a non-disclosure agreement, allowing the open discussion and test and verification, so that at the end, we can rely on the result that is published. So in some of our MHS, we have some materials for which it is a proprietary formulation, but we know that during the discussion, the full transparency was granted to our consultant to help him make the evaluation. So no secret will be said between us, but we can still provide the full transparency on the risk of the material we use.
Great, thanks Miriam, for explaining that process and that there are solutions to maintain transparency at the same time as maintaining confidential business information, intellectual property, yes. There's been a question on if we have information on baseline toxicity of different plastic components in different animals and aquatic life, etc. I don't have the reference right in front of me, but if you do read the introduction section of the document, it provides a reference to a report that was released this year that tabulated more than 10,000 chemicals and polymers that are used in plastics, and that report identifies where there are some data gaps for some of those chemicals, and it also identifies where some of those may have particular properties of concern. So that could be a reference that that you could look at for information on the toxicity more broadly of a number of plastic components. I think also, let's see. So there's one other question. So I think I'd like to ask just two more questions of the panel. And so one is quite specific. It says, what groups of chemicals and plastics are considered most important to avoid? It seems the use of phthalates in plastics gain more attention. And indeed, there are a subset of phthalates that have been regulated in many countries and therefore need to be moved away from in particular plastics. But maybe the three of you, do you have some reflections on what are some other groups of chemicals that could be targeted for more sustainable design? Maybe Susanna, I can go with you first.
Yeah, that's a very important but very difficult question. And a lot is really dependent on the application that is foreseen, of course. And we have in the Netherlands prioritized substances of concern. So the substance of concern under the REACH regulation, and we do like structural similarity modeling to see if there are chemicals used that are similar to those. And based on that, we have a list of potential substances of concern. I can share the link. But yeah, besides, like I said, it's a very tricky question and really depends on the application. I do not have really a satisfactory answer for that, I'm afraid.
Miriam, do you have some reflections from your side on that?
Well, that's something we have been dealing with for many years. So, of course, we paid a lot of attention and spent a lot of time finding alternative to phthalates that can be used in our floor coverings. But we took as well some radical decision regarding biocides that are not used in flooring because keeping for hygiene, good maintenance and cleaning protocol is enough for ensuring non-microbial growth on flooring. So sometimes there are overuse of chemicals, and that's as well what we have tried to reduce and to limit in our products. Some additive as well we have been working on that are stabilizers. We have not substituted them because of any toxicity, but just because they are limited quantities available. And they are not supposed to be used. We do not find them in natural elements. So there is no use to continue extracting them and so on. So there we found as well substitute to avoid the scarcity of those materials.
Thanks for those perspectives. And Timothy, do you want to add something to that?
Yeah, maybe a little sort of different tack. I mean, some of the chemicals that we're focused on specifically are actually kind of the legacy persistent organic pollutants and things like that in most jurisdictions have been phased out. But obviously, there are still manufacturers globally producing products with these chemicals in them. And then also we're dealing with the kind of legacy of the last 15 years of products that are now entering the waste stream and are candidates for recycling. And so it's not that they're currently necessarily in active use, but need to be detected, identified, and then directed to the appropriate fate once they reach that point of the product life cycle, rather than just being assumed to be suitable for recycling necessarily. So that's probably a slightly different answer, but that is nonetheless our focus.
Great, thanks all of you for those perspectives. And I'd like, thank you also all the participants for all of your questions, and we won't have time to get to them all, but I'd like to end with one question and gather some reflections from each of you on this. So actually this was in the chat function instead, and it says, so we say that, or I said in my presentation that complexity is high but can't be ignored. And the person is asking if we have any views, tips, or experiences on how to communicate this need for complexity towards decision makers in society, politics, and business. And I guess I would start by saying that we can't be scared to talk about chemicals. I mean, I think sometimes we avoid talking about complexity because it's too complex, and then we don't end up talking about the things that we need to talk about. And so I think just talking about chemicals and the complex nature of the decision making, and providing examples of where these trade-offs occur between policy areas are ways that we can communicate to others the challenges to moving towards more sustainable design. But I'd like just to get a brief response from each of you on yeah, if you have some tips for those who are trying to communicate this more sustainable design and its complexity to decision makers. Maybe we'll go with Timothy, and then Suzanne and Miriam to end with.
Thanks, Eva. Two quick thoughts from me. One is, don't just present problems, present solutions. If you can describe a problem and then present options for solutions, then I think that's a much more approachable topic for a decision maker. And I think this is where this particular initiative comes in as a valuable resource, right? It's not just articulating what the problem is, it's trying to provide that practical guidance to improve the outcomes. The other kind of reflection that I have here is that it's only once you get bored of telling people what the problem is that they finally start getting it. And you don't want to keep talking about it beyond that, but then all of a sudden there's this interest that ramps up, and so you are forced to keep talking about it, and that's coming from kind of personal experience here, and that's the stage that we're in. So really there is a broader recognition, and I touched on that in my comments earlier about the need to address this complex issue, and that definitely is emerging, and you can see that emerging globally as well.
Thanks.
Thanks.
Suzanne?
Yeah. Mm-hmm. I really do recognize that. I think indeed it's so important to keep talking about chemicals, to keep repeating. That's really important. Keep the conversation going. And I think also to stress that, like I said before, that it's a learning process. So it will be iterative cycles. So we have to start somewhere and not be afraid to start somewhere and then learn from that and build from that. But that also will mean not only for companies to be more flexible, but also for regulation to be more flexible, for instance. So if we're willing to be transparent and start and learn from that and then adapt again and see it like that way in circles, I think that will be very valuable.
Thanks. And some final thoughts from you, Miriam, on communicating this complexity?
Yes, so it's complex to deal with chemicals, but I think that Target at the scale of a large company, multinational, operating globally with global suppliers as well, we found a way to build up a community where we strive together to provide our customers with safe plastic materials and ensure them of transparency that can be made just because we get on well together, and to find solution and transparency. If you cannot tell everything about your product, there are always a way to have a third party supporting that. So to me and to Target, today, it's not a real issue, the problem of confidentiality. It can be managed. And that's how we can move forward with more transparency in the supply chains of plastics, because it has been mentioned in the chat. If you want to recycle materials, and especially long life span materials like flooring, in 20 years from now, you need to know what was in the product that has been installed. Because one of the problem of recycling we will have to face will be the unknown composition of the product.
Yes, absolutely. It's a challenge for many recyclers right now, yes. I think so. Well, with that, I'd like to draw this webinar launch to a close. So please do consult the documents. The links were provided in the chat for the documents, along with in my presentation earlier. And I thank very much Timothy, Suzanne, and Miriam for being here today also to share their perspectives. So thank you very much, and thank you to all the participants who joined in to hear about this new product, and we do hope it'll be a useful resource for companies, designers, and regulators and policymakers moving forward. Thank you.
Thank you very much. Goodbye.
Thank you very much.